This video is brought to you by mywayteaching.com.
Next, consider the problem. Here, calculate the amount of water, okay, so produced by the combustion of 16 gram of methane. So consider this problem, and for this solution is given by, I will explain the solution. Okay, so here the balanced chemical equation for this combustion you should write, which is in gaseous form when which is mixed with the oxygen, which gives carbon dioxide plus 2H2O. Okay, so this is balanced chemical equation. In this, first consider 16 gram of methane corresponds to is equal to 1 mole. Okay, like the second one, from the above equation, okay, 1 mole of CH4 gives 2 moles of water, correct? So just now consider 2 mole of H2O. Okay, water is equal to 2 into H2O, means molecular mass of water is 18 gram, which gives 36 gram. Okay, correct, which gives 36 gram. 1 mole of methane it gives here, as in that 1 mole methane gives 2 moles of water, correct? So 2 mole of water is 36 gram, like 1 mole of, now you conclude that 2 mole of water gives this. Next 1 mole of water is equal to, we know 1 mole of water is equal to 18 gram of water, correct? So 18 gram of water divided by is equal to 1 mole of water, so which gives 1, both are same na, 18 gram of water and 1 mole of water. Then consider 2 mole of water, you are obtaining 2 mole of water you in the product side, so into 18 gram of water divided by 1 mole of water, so that you getting that 36 gram of H2O. So this is the example. So from first, calculate the amount of water produced by the combustion of 16 gram of methane. So this is considering as 1 mole methane, so which gives a 2 mole of water. Okay, like 2 mole of water means which is of 36 gram, like the final answer is 36 gram of water, which gives 36 gram of water. Next question. Okay, like so please note it down, the example 1. Okay, next I will erase it. Okay, then again another example consider, please note it down. So these are the steps. So first you have to write the balanced chemical equation. First 16 gram of, they have given 16 gram of methane, which gives 16 gram of methane means which is equal to 1 mole. So here 1 mole of methane which gives a 2 mole of water. So 2 mole of water means 36 gram. So the next 1 mole of water means 18 gram, 2 mole of water means 16 gram. So that 18 into 2 mole of water which gives 32 gram of water. Okay. So consider the next example, the second one. So question is, how many moles of methane are required? How many moles of methane are required, okay, to produce 22 gram of carbon dioxide after combustion. Okay, so as a solution I will write here solution according to the chemical equation. Write down the first point, the balanced chemical equation. Okay, so here CH4, which 2 oxygen, this is a gas, so which gives carbon dioxide gas, so plus 2H2O, this is gas. Okay, so here 44 gram of 44 gram of carbon dioxide is obtained from the 16 gram of methane. How 44 gram of carbon dioxide? 44 gram of carbon dioxide is obtained. Okay, 44 gram of carbon from 16 gram of CH4, that is methane. Therefore 1 mole of carbon dioxide is obtained from the 1 mole of methane, is obtained from 1 mole of CH4 methane. Okay, next is you just calculate the mole of carbon dioxide. Okay, so mole of carbon dioxide gas. So here 22 gram of carbon dioxide gas into 1 mole of carbon dioxide gas divided by 44 gram of carbon dioxide gas. So here 22, this you are getting 0.5. Okay, so this goes, so mole of carbon dioxide gas, so hence 0.5 mole of carbon dioxide would be obtained from 0.5 mole of methane, or 0.5 mole of methane would be required to produce 22 gram of carbon dioxide. So this is the solution. So how many moles of methane are required to produce a 22 gram of water after combustion? So next, this is about, okay, and next is limiting reagent. Okay, so here next topic is limiting reagent. What do you mean by limiting reagent and all? So many a time the reactions are carried out when the reactants are not present in the amount as required by the balanced chemical reaction. Reactions are carried out also, but in such situations one reactant is in excess over the other. The reactant which is present in the lesser amount gets consumed after some time, and after that no further reaction takes place whether be the amount of the other reactant present. Okay, it means many a time the reactions are carried out when the reactants are not present in the amount as required by the balanced chemical equations. If the reactants are not present, then also some of the reactions are carried out. Okay, so in such situations one reactant is in excess over the other and the other reactant will be less. So hence the reactant which gets consumed limits the amount of product formed, so which limits the product. Okay, so that is called limiting reagent. Here one one reactant is in excess over the other. The reactant which is present in the lesser amount which gets consumed after some time, and after that no further reactions will be taken place, so whatever be the amount of the other reactants present, so hence the reactant which gets consumed, okay, reactants which gets consumed after some time, which gets consumed, and limits the amount of products formed. So this is called limiting. Those reactants are called limiting reagents. Okay, these reactants are called limiting reagents. So in performing stoichiometric calculations, this aspect is also kept in mind. Limiting reagent is also important. So just now consider the one example another example or problem for this calculation of limiting reagent. As the problem stated as 50 kilogram of